Hello and welcome back to the course on Python programming. Today we're talking about arrays in Python. Now this is going to be a short tutorial because we're going to be working with arrays in much more depth in the further sections of this course, but for now it's important for us to get a basic understanding of this concept. Alright, so let's quickly create a list. We've already talked about lists and we know them quite well, so let's just create a list of totally random numbers. There we go, so there's our list. So if I press Shift Enter, I have that list there. And we've already discussed that lists in Python are very similar to arrays in other programming languages like C, C++, or to vectors in R. But at the same time, lists have that property that they can store any mix of data types. So into this list, I could have easily put words, I could have put floating numbers as well as integers, and I could have put logical values and so on. But in Python, there's another concept which is actually called array. So that's another data structure. It's different to lists. It's similar in many ways, but it's actually different, and that's what we're going to explore today. So how do we create an array? Well, in Python, there are two types of arrays that you can use. There's the arrays that are built into the core of Python. They're called the arrays. There's also the Numpy arrays. So Numpy is a package that comes pre-distributed with Anaconda, and it's a package that you'll be using a lot. We've already actually touched on Numpy in the previous section of the course already when we were working with random numbers. Generally speaking, you'll be working with Numpy a lot, so it's basically a package that you include in most of your code, especially as a data scientist or data analyst. Numpy is just included pretty much all the time. And therefore, using the arrays that exist in Python in the core isn't the best option when you have the Numpy arrays, which are much more versatile and they have much more flexibility to them and much more control. So that's why we're not even going to bother with the arrays in Python. We're just going to go to the Numpy's arrays right away. So I'm going to add the Numpy package. So I'm going to say import Numpy as we discussed previously. But here I'm actually going to say as NP. That's a convention for Numpy, basically, so we don't have to type up Numpy every single time. We can just use NP. And you'll find that in most scripts that are written, you will find that NP is used instead of Numpy. So we're just going to run that code. And now if I say np.array, I have this function that will convert a list into an array. So if I pass it our list, L, you will see that as an output I have an array. So let's give it a name. Let's say A equals np array of L. And now if I type in A here, you'll see that that is our array. So now what's the main difference between lists and arrays? So why would we use arrays instead of lists? Number one, very important difference is that you cannot have an array of different data types. So an array is like a vector in R. You cannot have different data types inside an array. Let's have a look. Let's say we have an array called B, and we'll say np.array. And into this array, we want to pass the following list. We want to say 12, 455, then 63.3. So we've got integers, we've got a float, let's say a logical, and let's say a word, so letter A or ABC, for instance. So if we run that, and now we look at B, you will see that it is an array, but, or if I print B, you'll see that actually they've all been put into quotation marks, meaning that they have all been converted to characters or to strings because they had one string in there already, so everything was converted to strings. That's because you cannot have different data types inside an array. Everything has to be of the same data type. So that's number one. And then the question is, well, Kirill, why would we use an array if it's less flexible than a list? In a list, we can have different data types. In an array, we can't. So why don't we just stick with lists? Well, the answer to that question is there's a few benefits of using arrays, and they're quite substantial. For example, if I take my list and I press L and then press dot and I press tab, because the list is we are in an object-oriented programming language, well, what happens is there are functions or methods that are included in this object that they're being stored alongside with the data. So the data that we have, let's just press escape there. We have this data in the list, right? Well, actually alongside the data, because it's a list inside Python, it also stores these functions inside this object. So I can actually call these functions right now from inside this list. So let's say, for instance, I could say l.pop. What will that do? So if I run this function, you'll see that it gives me minus 1, 2, 3, 4. It gives me the last value of this list. So it shows it to me and it actually pops it out of the list. That's why it's called pop. So if I look at L now, you'll see that it doesn't have that value anymore. So I actually called a function from inside the list. Well, arrays have the same thing. So if I look at a dot tab, but you'll see that they have way more functions, and that, well, actually they're called methods, way more methods available. So for instance, I could right away say a max or a mean. So let's try the mean. I can just calculate the mean like that. Very quickly, I have the mean of this array that I have created here. So the average of those values is 4559. Very versatile and very powerful functions available inside arrays, or for arrays that come with Numpy. And so because you have that very strong package of Numpy backing this whole concept of arrays, that means that you have all of these powerful tools at your disposal. That's number one. And number two is that further down in the course, you will see that we will start creating multi-dimensional objects. We'll start creating specifically two-dimensional objects. We won't go much further than that. Don't worry, we won't go into 5 dimensions and so on. We'll be creating multi-dimensional objects, and specifically we'll be creating matrices. And a matrix is a two-dimensional array. And we'll talk more about that further down the course, but it's just important to understand that we will need to work with arrays just because we want to start working with tables, and then eventually we want to move on to, that will help us move on to data frames and so on. So just for data analytics purposes, it's inevitable for us to start working with arrays, so it's a good thing to get introduced to them here. So that's how you create arrays. You just basically take a list and you pass it into NP array. There you have it. After that, you have an array that you can work with. So just to get familiar with the concept, I encourage you to quickly practice this and maybe create a few different arrays. So see for yourself, for example, what happens if you don't include a string, what will happen if you include a mix of data types that are just integers, floats, and logicals. What will that array convert all of those values to? So things like that, and just practice creating some arrays, check out some other functions that exist in there. And that will help us get a head start into the concept of multidimensional arrays when we get to it. Hope you enjoyed this tutorial, and I look forward to seeing you next time. Until then, happy coding.